Welcome to the new session of the course of differential equation. In this session, we will discuss about the general solution and the basis. We already discussed about the linear second order differential equations. That is generally we can say that y double dash plus p of x y dash plus q of x y is equal to r of x is the differential equation, or maybe sometimes we may write this is equal to y double dash plus p of x y dash plus q of x y is equal to r of x. The same the representation is, instead of capital P of x, q of x and r of x, we just change it as small p of x, small q of x or small r of x. Maybe based on context you may understood it is that, and maybe sometimes we may write we may change the variable as, instead of x and y, maybe y and t is there, y double dash plus p of t y dash, p of t y dash plus q of t y is equal to r of t. Q of t y is equal to r of t. Okay. Say so we can say that these are all the different forms of the second order linear non-homogeneous differential equations. That is in this the representations may have a little changes, but all are similar and equal. Mostly we can say that they are equal. Okay, anyway, see my dear students, we can say that second order homogeneous linear differential equation is of the form y double dash plus p of x y dash plus q of x y is equal to 0. See this, I would like to consider this as equation number 2. Okay. Now in this session our discussion it is that this is there are two solutions maybe. See y1 and y2 are two solutions of this differential equation, that is maybe y1 is equal to y1 of x and y2 is equal to y2 of x are solutions of the differential equation 2. See, these are two solutions of the differential equation 2. Our question is that we already discussed it, is that c1 y1 of x plus c2 y2 of x are solutions, are solution is the solution of equation number 2. Okay. This is discussed in fundamental theorem that the session just we before discussed. So my dear students, here before going to discuss about the basis, I would like to say the linear dependency and independency of two functions. Okay, let's y1 of t and or y1 of x, simply I would like to use the variable as y1 of x and y2 of x are two functions defined and defined on an interval I, defined on an interval I. So y1 and y2 are two functions defined on an interval I, and if they are proportional we say that they are linearly dependent. If y1 y2 are proportional, how can we say that they are proportional? See, if either, that is if y1 and y2 are proportional, then if y1 and y2 are proportional, then y1 and y2 are proportional, then they are linearly dependent. Then they are linearly dependent, then they are linearly dependent. See, my dear students, if y1, y2 are the functions, how can we say that they are proportional if one is the multiple of the other, constant multiple of the other? See, this one, if y1 of x equal to c y2 of x for some constant c cy2 of x for some constant c, then we say that y1 and y2 are linearly dependent. For example, maybe see, y1 is equal to x, y2 is equal to 2x. Okay, so y2 is actually the constant multiple of y1, 2y1. Therefore, y1 and y2 are linearly independent. See, y2 divided by y1 is equal to 2x divided by x, that is equal to 2. Okay, that is equal to 2. Therefore, is a constant. Is a constant. It's a constant. Or y1 divided by y2 is equal to x divided by 2x. Therefore, we say that this is equal to x by 2x, this is equal to 1 by 2. Okay, is also a constant. If the ratio of two functions is a constant, if the ratio of two functions is a constant, then we say that both the functions are linearly dependent. They are linearly dependent. So, my dear students, we can say that these functions x and 2x are linearly dependent. See, dear students, maybe in the case of example, this is equal to y1 is equal to e raised to x, y2 is equal to 2 e raised to x. See, y2 divided, therefore, y2 divided by y1 is actually this equal to e raised to 2x divided by 2 e raised to x divided by 2 e raised to x divided by e raised to x. Okay, so we can say we can cancel this e raised to x and e raised to x. Finally, the value will be is equal to 2. Finally, the value will be 2. Therefore, y2 divided by y1 is equal to 2. Therefore, y2 divided by y1 is equal to 2. Okay, fine. y2 divided by y1 is equal to 2. So, the ratio is equal to a constant. Therefore, we can say that y1 and y2 are linearly dependent. y1 and y2 are linearly dependent. Okay, see, while moving to the next example, we just move to in the next example, we say y1 equal to e raised to x, y2 equal to e raised to 2x, e raised to x, y2 equal to e raised to 2x. Say, dear students, we can say that y2 divided by y1, y2 divided by y1, that is equal to e raised to 2x divided by e raised to x. See, we are unable to cancel this. So, we can take this to here. So, we can write this is equal to e raised to 2x minus x is there, that is equal to e raised to 2x minus x is actually e raised to 2x minus x is e raised to x. Okay, y2 divided by y1 is equal to e raised to x. This is not a constant. Is not a constant. See, my dear students, the ratio of two function is k in a function. So, that is not a constant. So, that we can say that here y1 and y2 are linearly. Therefore, y1 is equal to e raised to x and y2 equal to e raised to 2x are linearly independent, are linearly independent, are linearly independent. So, actually we can say that if the ratio of two functions is a constant, then that two functions are linearly dependent. Otherwise, if the ratio is again a function, is a non-constant function, then we can say that that is that two functions are linearly independent. See, my dear students, we can write this is one more example. Y1 is equal to 40, y2 equal to 60. For the variable will change it, instead of x we just change it to variable into t. Therefore, y2 divided by y1. See, my dear students, we will have y2 divided by y1 is equal to 60 divided by 40, that is equal to, we can cancel t and t can remove from here, and finally 6 by 4 is there, that is equal to 3 by 2 is a constant. So, we can write this is for y1 equal to 40 and y2 equal to 60 are linearly dependent functions, are linearly dependent functions. So, dear students, we can find many such questions in the literature, and we already discussed there are different solutions of the differential equations, like we have in the two previous sessions we discussed, it is that y double dash plus y is equal to 0. Okay. This is a second order linear homogeneous differential equation. Here y1 is equal to cos x and y2 is equal to sin x are solutions of the differential equation 1, are solutions of differential equation 1. See, my dear students, these two are the two particular solutions of the differential equation 1. As according to this, we can say that their linear combination is also solution that we discussed in the case of the fundamental theorem that we discussed just before. But here, what about these two functions? These two functions are the solutions of this differential equation. So, we can say that this is equal to y1 divided by y2 or y2 divided by y1 is equal to sin x divided by cos x, sin x divided by cos x. Actually, we know this is equal to tan x, is never be a constant value, that is a function. Therefore, we can say that y1, y2, these are cos x and sin x are linearly cos x. Therefore, cos x and sin x are linearly independent. See, maybe C1 cos x, C2 sin x are linearly independent. We also can say like that also. See, I would like to put one more value, one more function, y3 is equal to 2 cos x. See, y3, see y3 is equal to y3 is equal to 2 cos x. See, y3 divided by y1 is equal to 2 cos x divided by cos x. So, definitely we have the values, we can cancel cos x and cos x. Finally, we will have the value is equal to 2. So, y3 divided by y1 is a constant. Therefore, y3 and y1 are linearly dependent. See, my dear students, y3 and y1, y3 is 2 cos x, that is a constant multiple of y1. So, from the definition itself, that is, we can say that that is linearly independent. So, they are linearly dependent. Okay, fine. Similarly, have we able to say, see, e raised to, in the next example, we can write e raised to, say, e raised to 2x and e raised to minus 2x are two functions. I would like to put e raised to 2x as y1 is equal to e raised to 2x and y2 is equal to e raised to minus 2x. y2 divided by y1 is equal to, we can say y2 divided by y1 is equal to this is e raised to minus 2x divided by e raised to 2x. Maybe you can take this is to here, that is e raised to minus 2x that is equal to e raised to minus 4x. This is not equal to a constant. So we can say, we say that this is not a constant. That is not a constant. See, that is not a constant, and also we can say that this is equal to e raised to e raised to minus 4x is there, is not a constant. So that we can say that y is equal to e raised to 2x and e raised to minus 2x are linearly independent. See, my dear students, one more thing is that I would like to say this is I would like to consider a differential equation y double dash minus 4y is equal to 0. Okay, I would like to consider a differential equation. This is second order homogeneous linear differential equation. Say put y is equal to e raised to 2x, okay, e raised to 2x, and y dash is equal to 2e raised to 2x, y double dash is equal to 2 into 2 4e raised to 2x. Okay, so y double dash minus 4y, y double dash minus 4y is equal to, y double dash is actually 4e raised to 2x, 4e raised to 2x, 4e raised to 2x minus 4 into y is actually e raised to 2x. So therefore this is equal to 0, satisfies the differential equation, that satisfies the differential equation, this differential equation. So that we can say that e raised to 2x is a solution of differential equation. And similarly, I would like to say this is y is equal to e raised to minus 2x, y is equal to e raised to minus 2x is here. See, think about y dash is equal to minus 2 e raised to minus 2x, okay, minus 2 e raised to minus 2x, and this is y double dash is equal to minus 4, sorry, minus 2 and minus 2 plus 4 a raised to minus 2x is here. Okay, put in 1, the equation 1, put in 1, so that we can say that this is equal to this one y double dash minus 4y is equal to y double dash is equal to 4e raised to minus 2x minus 4 into y is e raised to minus 2x. So this is equal to 0, satisfies the equation 1. So that we can say that, therefore we can say that y is equal to e raised to minus 2x is also solution of y double dash minus 4y equal to 0. So they both are the solutions of the y double dash minus 4y is equal to 0. So homogeneous equation, linear homogeneous equation, according to fundamental theorem we can say that, according to fundamental theorem we can say that this is equal to, sorry, according to fundamental theorem we can say that y is equal to c1 y1 plus c2 y2 is also a solution. So is also a solution of 1. So the solution is, that is y is equal to c1 is arbitrary constant e raised to 2x plus y is equal to plus c2 e raised to minus 2x are the solutions. So is the solution of the differential equation. See, my dear students, I drag your thoughts to it is that these two are the linearly independent solutions of the, these two are the linearly independent solution of the differential equation y double dash minus 4y is equal to 0, and their linear combination is also again a solution. Okay, fine. Similarly, we can write this is y is equal to t and 1 plus t are the linearly independent functions. So, you can find many functions that are linearly independent, and you can find the functions that are linearly dependent also. And what we discuss it is that in this context of the differential discussion of the differential equation, we discussed it is that these two functions are linearly independent. They are the linearly independent solutions of a differential equation. See, that is my next definition is that the basis of the differential equation. The basis of a differential equation it is that I can say that this is e raised to 2x and e raised to minus 2x is a basis of a differential equation or the fundamental system of a differential equation, because they are linearly independent. They are the solutions of the of a second order linear homogeneous differential equation. See, similarly I can say this is y is equal to cos x and y2 is equal to sin x. So, I can say that by the fundamental these are the solutions of this homogeneous linear differential equation. So, by the fundamental theorem we can say that say y is equal to c1 cos x plus c2 sin x is also solution of this linear homogeneous differential equation, and they are the linearly independent. So, what we found it is that they are the linearly independent solutions of the system second order linearly independent solution of the system of linear homogeneous differential equation. So, these the functions will form a basis. So, sin a cos x and sin x is called this one basis of this differential equation. So, two linearly independent solution of a linear homogeneous second order differential equation on an interval I where the differential where these functions are defined is called the basis or fundamental system of the this one fundamental system of the solution on I. Okay. So, we can find many solutions. As we said here it is that 2 cos x is a solution, 3 cos x is a solution, and cos x is a solution, 2 cos x is a solution, 3 cos x is a solution, and so we can have a set of solutions, maybe have very infinite number of solutions, have the possibility to be infinite number of solutions may have the equation 1. So, we can say that these two cos x and sin x are two solutions of a linearly independent solutions of a second order linear homogeneous differential equation defined on an interval I. So, we can say that they are the basis or fundamental system of solutions on I. So, that is actually here. So, we can say that in generally we can say that if y1 y2 are, see my dear students, if y1 y2 are solutions of second order linear homogeneous differential equation, linear homogeneous second order differential equation, linear homogeneous second order linear homogeneous second order differential equation, then we can say that if they are linearly independent, if they are linearly independent and defined on an interval I, then we say then y1 and y2 are basis of the given differential equation or fundamental system of fundamental system of solutions on the interval I where y1 and y2 are defined. Okay. Fundamental system of solutions on I. Okay, fine. So, we can say that if y1, y2 are the linearly independent, the next one we say that, and this one not, if y1 and y2 are basis of homogeneous system, homogeneous linear second order differential equation, y double dash plus p of x y dash plus q of x y is equal to 0, then we say C1 y1 plus C2 y2 is the general solution of given homogeneous linear second order differential equations. See, my dear students, so that is what is called the general solution of the. So, we can say that C1 y1 and C2 y2, C1 y1 plus C2 y2 is a general solution of 1 if y1 and y2 are defined on an interval I and they are the linearly independent solutions of y double dash plus p of x y dash plus q of x y is equal to 0. Okay, see, I would like to discuss an example with you is that, see, consider a differential equation y double dash minus y dash minus 2y is equal to 0. Y double dash minus y dash minus 2y is equal to 0. Minus y dash minus 2y is equal to 0. So, consider the functions as y1 is equal to e raised to minus t, y1 equal to e raised to minus t, y2 equal to e raised to y2 is equal to e raised to 2t. E raised to 2t. Our task is that check whether y1 and y2 are solutions of the given differential equation 1, and also check they are linearly independent or not, and also check they are linearly independent or not, and then find the find the linear and then find the general solution, See, we have given two function y1 is equal to e raised to minus t. So, just we have to find given y1 is equal to e raised to minus t, y1 dash is equal to minus e raised to minus t, y2 dash is equal y1 double dash is equal to e raised to minus t itself. Okay. So, we can say that this is equal to y1 double dash minus y dash minus 2y is equal to 0. So, we have this is equal to y1 double dash. So, y1 double dash minus y1 dash minus 2y1 minus 2y1 is equal to y1 double dash is equal to e raised to minus t minus y1 dash is equal to minus e raised to minus t, that is equal to plus e raised to minus t minus 2y1 minus 2 e raised to minus t is there, that is equal to 2 e raised to minus t is equal to 2 e raised to minus t minus 2 e raised to minus t is there equal to 0 satisfies the differential equation 1. That satisfies the differential equation 1. And similarly, we can say that we can take y2. y2 is equal to e raised to 2t. y2 is equal to e raised to 2t, e raised to 2t, y2 dash is equal to 2 e raised to 2t, y2 double dash is equal to 4 e raised to 2t. y2 double dash is equal to 4 e raised to 2t. Okay, so apply in 1, therefore we can write therefore y2 double dash minus y2 dash minus 2y2. Okay, that is the differential equation. I think this is equal to y2 double dash minus y2 dash minus 2y2. If it is equal to 0, we can say that satisfies the equation, then that will be the solution. So y2 double dash is equal to y2 double dash is actually y2 double dash is equal to 4 e raised to 2t. 4 e raised to 2t minus y2 dash, that is equal to 2 e raised to 2t, that is equal to 2 e raised to 2t minus 2 e raised to 2t minus 2 e raised to 2t, that is equal to 4 e raised to 2t minus 2 e raised to 2t minus 2 e raised to 2t, that is equal to minus 4 e raised to 2t. Okay, this is equal to minus 4 e raised to 2t, that is equal to 0. So we can say that both this satisfies the equation. So we can say that this both e raised to minus t and e raised to 2t are the solutions of the given differential equation, second order homogeneous linear differential equation. So by the fundamental theorem, we can say that their linear combination c1 y1 plus c2 y2 is again the solution. See, my dear students, we have to check whether they are linearly independent or not. See, y2 divided by y1 is actually to check independency, to check independency of the function, that is y2 divided by y1 is actually equal to y2 divided by e raised to 2t divided by e raised to minus t, e raised to 2t divided by e raised to minus t. Okay, we can take this e raised to minus t, we can take this e raised to minus t, t to here. Okay, fine. Therefore, e raised to minus t will be plus t, e raised to 2t plus t equal to e raised to 3t, not a constant. Not a constant. So y1 and y2 are, therefore y1 is equal to e raised to minus t and y2 is equal to e raised to 2t are linearly independent, and not only linearly independent, are the solutions of the differential equation, y double dash minus y dash minus 2y is equal to 0. So therefore, their linear combination will be the general solution. Hence, we can say that hence we can say that y is equal to c1 y1 c1 e raised to minus t plus c2 e raised to 2t, c1 e raised to minus t plus c2 e raised to 2t are is the solution of, is the general solution of, is the general solution of the differential equation y double dash minus y dash minus 2y is equal to 0, y double dash minus y dash minus 2y is equal to 0. So, dear students, this is the general solution. So, here C1 and C2 are called the arbitrary constants. That means they can choose the values as their own wish. So, the differential equation may have infinite number of solutions. And also, dear students, maybe in case of in some cases maybe there will give two conditions, that is what is called the initial conditions, or sometimes some conditions are called the boundary conditions. The initial condition, if t naught or x naught is the initial point of the domain, so at that initial point if they given a particular values for y at x naught and y dash at x naught is there, then we can apply here apply the values of y of x naught and y dash of x naught, and after we can solve this differential equation, then we can find the particular values for the C1 and C2. On that case, we will have a particular solution. And similarly, maybe in case of boundary conditions, that is where they will give if A and B are the boundary points of a domain where the y1 of x and y2 of x are defined. Say on that points if y of A and y of B is there, so we can apply y of A and y of B values here, and finally we will have the value. Finally, we will have the value of differential equation is there. So fine, and okay. So this is the form of the we discussed the basis and how can we form the solution for general solution from the basis that we discussed here in this session. Okay, dear students, so the basis is actually the two linearly independent solution of a non-homogeneous linear differential equation, and that is also called the fundamental system. So that is what is called the basis of the solution. Also, I would like to give you one more assignment to you. Check whether t and t plus 1 are linearly independent or not. Also, write down the next question. Check whether e raised to t and 3 e raised to t are solutions of the differential equation, y double dash minus 2y dash plus y equal to 0, y is equal to 0. Okay, fine. Also check whether they are linearly independent or not. Okay, fine. Try to work out these two problems. There are many problems that we can discuss in the upcoming sessions, and we can discuss in coming sessions on the initial value problem and also boundary value problem also. Okay, thank you for watching this videos. Continue watching. Thank you very much.